Okay, let's talk about GrabCAD Print Pro features common to our big three technologies. Whether you've got our F123s or Fortis series, our PolyJet J series, or our SAF H350 powder bed series, there are certain features in Print Pro that you can use with all three technologies. Let's take a look at them in the order you're probably going to use them the most. For costing, in GrabCAD Print, if you're using a local connected real printer, it is set up under the printer details. From there, you go to settings, and from there, you go to costing rates. And from there, you'll see a screen that looks like this, where you can put the dollars per cubic inch of material and support, and the dollars per hour you estimate it takes to run your machine. Entering in these numbers will save it on your installation of GrabCAD Print Pro, so each of your coworkers will have to enter the numbers as well if you want to use the same numbers. That's for a connected local, real physical printer. If you're working remotely like I am, you're using a template printer, and the costing is set up under the Estimate button. So put a part in the tray, hit Estimate, and you'll see costing rates. If you click on that, you'll get to the same screen as we had before, where you can put in material and support costs. One interesting thing to note here is if you've chosen an F170 printer, you'll get a certain set of materials which the F170 can print. But if you've chosen an F370, you'll get even more materials, since the F370 can print more. And if you've chosen an F450, the list of materials goes off the page, since the F450 can print even more. You'll have to set up costing rates for each material you want to print and calculate, so make sure to budget the time for that. Here's an example for the F370. I just looked these prices up online. They'll vary by your region of the world and your reseller, and if you're an educational customer or not. But I just looked up the price of the spool online and divided by the capacity of the spool, and you'll see that ASA is about $4 per cubic inch. The carbon fiber ABS is about $5.7 per cubic inch, and the support material for both is about $3.6 per cubic inch. So those are the numbers we're going to use. Okay, so here's an F370 tray. I put a bunch of parts on it. I'm going to go down to view estimates, and you can see the total cost is 0. So I'm going to go to costing rates, and let's put in those numbers we just calculated. $3.9 cubic inch for ASA, 3.7 for the support, and let's say $10 an hour to run the machine. Go hit save, and now you can see we've got a cost for the entire tray. We also in FDM have a cost breakdown per part, which we can easily export to Excel. Now we're going to do the same thing for PolyJet, just so you and I can understand the difference in magnitude of the numbers. Googling these numbers for my region, color material is about $352 per kilogram, draft gray is about $152, and support used for both is about $123 per kilogram. Switching over, now I've got a PolyJet J850 tray. I'm going to go down here and hit estimates. You can see the cost is 0. Let's go to the costing rates and type in the numbers we just found. So $352 per kilogram, and the support is $123 per kilogram. This machine might be more expensive to run, so let's say $30 per hour, and then hit save, and you can see we now have the total cost of this PolyJet tray. One last example with H350. The costs for these were a little harder to get online, so I just asked around our shop, and what they found is that for the high yield PA11, it was about $60 per kilogram. For the PA12, it was about $48 per kilogram, and the high absorption fluid was about $450 a liter. And jumping to GrabCAD Print, we've got a stacked and packed H350 tray. I'll go down to view estimates. You can see the cost is 0. So let's go to the costing rates again and put in those numbers. $60 a kilogram for the powder, $4.50 a liter for the fluid, and I've heard this machine takes about $15 an hour to run. Okay, there's also these per part cost and per part supplemental for cleaning, vacuuming, bead blasting. If you want to do anything like that, you can put those in separately. But let's go ahead and hit save. And you can see now we've got a total cost for the whole tray. And just like in FDM, we can see a build summary where every part is broken down one by one. And you can export this all to Excel. And that's costing for the three technologies. I'm not going to show you every feature for every technology, but I at least want to do this one, since this is the feature you'll probably be using the most. Let's move on to labels. You get the labels by right-clicking on the body, and then you get a dialog where you can edit your text, choose if it goes in or out of your body. You can choose the font size and the depth. And then when you hit update, it'll look like this when you print it. You can even do things like putting part numbers on the side, so it'll look like this when it's printed. The great thing about labels is it works on flats and it works on curves. It works on CAD files and it works on STLs. Let's do an H350 example because it's cool. I've got a single part here on the infinite plane, and if I right click and choose add label to body, you see I get this no smoking sign, and that's because the body hasn't been checked. So let's go up the top right and check the model for goodness. It should come out okay. And now when I right click, I get the label choice. So I can place it anywhere I want, and I could put in some text, but there's a cooler option. That's if you put a template in. So let's make a template, a new template. Just choose the part name and hit insert. And then go choose to put a number after it. Hit insert again. And you can choose to change the font or whether it goes in or out of the body, emboss or deboss. And you can change the font size. But once you hit update, you'll see that part name and then number on the part. If you hit update, it'll actually be baked into the model. There we go. Now it's baked into the model. And here's when the cool things happen. If I hit duplicate and I make 50 copies of this part, the label will go with the 50 copies. Okay, so right now the label is just says -1 because it's the first one. But if you hit update at the top right, you'll see all 50 labels update with their number. See that one says 50. If I zoom out a little bit, this one's in the 40s. Okay, so put your labels on first before you duplicate the part, and it'll make it easy automatic numbering. All right, so that's labels for all three technologies. Now let's look at the next most used feature, thickness checker. What we're doing is analyzing a part, and GrabCAD Print will tell you if it's safe or if it's too thin to print. You can see a little of this in FDM if you look at the slice view. You can see that this wall has 3 beads across it, which is probably enough. Then you get into 2 beads, which is kind of our minimum recommended. And then you get into 1 bead. And the 1 bead walls will tend to fall over because there's not a second supporting bead. And that's sort of what we're looking for as well with this thickness checker. So that's the general physical concept we're looking for in FDM, but we have to put numbers to it to apply thickness checker. If you think about the 2 beads in FDM, you can think about your layer height being Z. Each bead is about 2 times that, give or take. So you want about 4 times Z as your minimum thickness. You can do the math, but a good rule of thumb is to start with 1 millimeter and go from there. For PolyJet, a colored model has 1 millimeter of color on the outside, then 4 millimeters of white in the middle to provide an opaque backing, and 1 millimeter color on the other end, for a total of 6 millimeters. If we're using our new ultra white, you only need 1 millimeter for the backing in the middle, so that makes it 3 millimeters total. And if you don't care about color, if you're just looking for a single color, you can get by with a ½ millimeter for PolyJet. This ½ millimeter shows up again and again. It's sort of a minimum recommended distance for SAF and origin, and then the Neo has different numbers depending on what direction you go. But make a chart like this for your own technologies and use that to input into the thickness checker. Also, you may notice that this video is just for FDM, PolyJet, and SAF, which is what GrabCAD Print Pro currently supports. But what we're saying is Thickness Checker can analyze any part you want on an FDM tray, for example, and then you just switch to an Origin or your Neo software once you have that part analyzed to know that it's good to print. So let's see what that looks like in the software. All right, here I've got a full FDM tray, and the first step is to check those parts for goodness. So I'm going to go to the top right, and we'll check the parts for water tightness, make sure the faces are correct, and everything comes out good. In this same area right next to it is the thickness checker right there. So I'm going to click on the thickness checker, I'm going to type in 1 millimeter like we talked about before, and then we select all the models on the tray and hit Analyze. One good thing about thickness checker is that you can check the entire tray at once. Makes things really efficient. And here we go. Most everything looks good. There's a couple of thin areas on the tail of this manta ray, and you can even hover over the red areas to see there's only 0.7 millimeters of material there. Now, if I want to show more red for this video, I'm going to grab this thickness amount and increase it. It's a little bit counterintuitive, but what you're setting is the floor for minimum acceptable thickness, so increasing it gives you more red. And that was a thickness checker. These last two features, 3D array and grouping, will go pretty quick. For 3D array, the entire point is to stack your parts in Z. This is something you could always do on the powder bed SAF systems, but now we're introducing it to FDM. The print may take a little longer, but if you're printing volumes of parts, you have to do fewer tray switch ins and switch outs, so it's more efficient. Alright, here's a single part on the FDM 450 tray. The button for 3D array is down here on the lower right. I'm going to select the part we want, and how many do you want? Let's say 3 in this direction. Let's say 3 in the other direction. Okay, I can flip around the direction here, and let's go back to maybe put only 2 in the X direction because it's getting a little spacey here. And now let's add in Z. Okay, let me just click up, up, up. So experienced users will be able to tell that, yeah, we're going to have support between these models on the tray, but if you want to print just one tray over a long weekend and get all these done, this may be more efficient than coming in and switching out the tray 5 times. And once you do this, you can go to the feature tree on the top left, and you can see you now have a feature for 3D array, which you can dissolve or edit or things like that. And one last caveat for this, everything we've seen up until now has been for FDM, PolyJet, and SAF. This is one of the features that is just for FDM and SAF. We hope to have the PolyJet features for this very soon. That was 3D array, now let's look at grouping. Grouping refers to having multiple parts on a tray, selecting them at the same time, and clicking the group button at the top to make them one digital entity. So why would you want to assemble or group things? Well, I've got two separate SOLIDWORKS parts here on the tray, not touching, and if I try to slice them, GrabCAD Print is cool with that. Okay, it slices each one individually. But it seems inefficient, right? It seems like that cone should be able to fit inside that ring to save a space while printing. The previous workaround was to make an assembly in CAD. So now you see on the left-hand tree, I've got one SOLIDWORKS assembly with both those parts. And with one digital item, you can grab in GrabCAD Print and slice it, and the slices work out just fine. If you make an assembly in upstream CAD, you're still okay. So now we're just doing that step in GrabCAD Print. I'll go to another tray here. Okay, you can see it's giving me the red error. This is not an assembly in CAD. This is just the two part files from before. And if I try to slice it or do anything, it gives me the red error. They can't fit. They're overlapping, right? So now I'm going to grab both these parts, Control, grab both, and up the top it's assemble, and I can make an assembly right here in GrabCAD Print. And now if I slice it, now it works fine. GrabCAD Print can slice it and understand it because it's one digital assembly. But wait, you're saying, that was just the assembly command. We haven't used the group command, which is what this whole section is named after. Why would we use group and not assemble? Well, let's go a little deeper. So here I've got two separate part files again, just like the cone and the ring from last time, but this time I don't want them to be just inside an empty space. I want them to overlap and merge. So I'm going to grab the smaller body and move it to where I want. And just like before, I'm going to grab them both and hit assemble. But now I'm going to grab that assembly in the tree and add one more step, which is the group. And you're doing that for a very specific reason. And that reason is underneath the model settings, a very specific flyout right here. The group behavior of separate bodies or combined bodies. Because with the ring and the cone, nothing was touching. But now that they are, with these squares, we have to tell GrabCAD Print what to do when they're touching. So let's say separate bodies. I'm going to choose solid infill for both of them, and then we'll slice it. And if you look at what happened, you can see there's a seam here where the old parts used to meet. It's like the toolpaths aren't stretching between the part files. Sometimes you want that, but most times you don't. It's like it's not really integrating the toolpath. So let's go back. We'll choose the part files again in the settings, model settings, and this time combine the bodies. Now we'll slice them again. And now it's like the parts are really integrated. Okay, there's no seam in between the two parts like there used to be. The toolpaths stretch between the parts. And that's the power of grouping them. So, to go over the workflow, you grab a bunch of parts, you hit assemble, and that might be good enough, but to integrate the toolpaths, you go one step further and hit group. Okay, so that's grouping in GrabCAD Print Pro. To recap, you're probably going to use costing, labels, thickness checker the most, but those other features will be helpful too. In the next video, we'll talk about splitting out into FDM specific features, PolyJet specific, and SAF specific features.